Everyone, so today we are going to solve a very interesting and popular problem number 560. Subarray sum equals k, and the problem says given an array of integer nums and an integer k, return the total number of subarrays whose sum is equals to k. A subarray is a contiguous non-empty sequence of element within an array, meaning that one from 0 index and 1 index is considered as subarray, and 1 2 from 1 from index 1 and 2 are considered as subarray, not 0 and 2 indexes 1 1 are considered as subarray. Okay, so one elementary approach would be to use two for loops and traverse the for loop and sum each element with each other and look for the total sum of 2, and wherever this count becomes equals to 2, we'll increase that. One will keep one counter to keep a count like when we are reaching that equality of k sum, and then we can return the just count. So that approach would give us the solution in time complexity of O of n square, so which would not be very efficient solution. So the real question is, can we do better? And the answer is yes, we can do better. And here is how we can do better in this case. So what we'll do is, so let's say we have this subarray 1, 2, 3, 5, 6, 7, and there is k is equals to 5 that we are looking for this sum, and we have the indexes of these array elements over here. So what we'll calculate is we can calculate the prefix sum of each index position. So that would be 1, 3, 6, 11, 17 and 24. And now we'll observe that if my in this prefix sum, if my for any sum, if I subtract sum k, and if I find a prefix sum which already exists previously, then I can definitely say that this is the subarray which has sum equals to 5. So for example, this subarray, this prefix sum of 6, if I subtract 5 out of this, then we are left with just 1. So then this means that there is one subarray which has a sum of 5, because that's how I am able to get this 5 out of this, and which is 2 in this case, that 2 and 3 has is a subarray which has a sum of 5. So we can similarly see this for another example. So if we are looking from start till 11, and if I'm subtract 5 from 11, I have the prefix sum of 6 till here, then this subarray, then this portion of the array is one subarray which has a prefix, which has a sum of equals to 5, so which is true also in this case. So in total there are two subarrays, 2 and 3, which has sum equals to 5, and we want to just return the count of these subarrays, so which is 2. And to look up into this subarray sum, what we'll do is we'll create one hash map of sum that we have seen. So we'll start with 0 initialize. So for 0 prefix, its frequency is 1. For 1 we have 1. For 3 we have 1. 6 we have seen it 1. So this we will create as we are iterating the array, and 17 and 24, and we'll look the remaining sum in this hash map that we have created, and then we can increment our answer counter. So which will be clear once I start writing the code, and here is how we can write the code for this approach that we have developed over here. So now let's get into the coding part of this. So like we defined, we have one s variable equals to 0. We'll initialize it 0 and we'll create one hash map to keep the count of prefix sums that we have. So we'll initialize this with 0 prefix sum, which frequency is 1, and we'll keep one answer variable to store a result. And we'll start traversing in the array nums, and we'll add the numbers in the variables, so which will give us the sum that we are looking for, and we want to create the hash map of this sum. So that would be, so if that sum is not present for the very first time, then we'll say that count.get default value of this sum is 0, otherwise increment this sum by 1. And now when we see that if this s minus k, which is the remaining sum, is in my hash map that I have just created, then we'll increment the count of our answer variable with the count of the hash map value that we are seeing. And in the end, we want to just return this in answer that we are looking for. So now let's run our example test case and see that this is what we have observed and this is what we are looking for. So we have 1 2 3 4 1 2 3 5 6 and 7, and we are looking for a prefix sum of 5. So now let's run our code and see how it performs. So it's giving us the expected output that we have constructed over here, the algorithm that we have constructed. So this is, and now let's submit our solution and see how it performs for the whole problem that we have created. So it has been accepted and it's running pretty fast. So this is the algorithm to find the subarray sum equals to k, and the time complexity for this is O of n, because we are doing everything in one pass, where n is the number of elements in the array nums, and the space complexity is also O of n, where we are creating the prefix sum for each indexes of the array nums. So that's how you solve this problem. I hope you guys are liking my solution, and if you have any particular problem request, please let me know, and please like and subscribe to the channel. It helps me in creating more awesome content for you guys. Thank you. Have a nice day.